Welcome to the future.
Welcome to the Muxall Open Internet of Things video blog. I am your host, Michael Crane. In today's video, we are going to fire up our LTC2984 multi-sensor high-accuracy digital temperature measurement system with EEPROM, set up the SPI, and see what kind of temperature readings we can get out of our PT100 RTD, a PT1000 RTD, and an off-chip diode. And I use diode in quote marks, okay? Because this video got to be over an hour long, I went ahead and have split the SPI code deep dive into the next video, number 31. So it took me over 2 days to get this chip up and running. I'll show you why. Okay, so let's get started by reviewing the schematic real quick. Make this a little bigger here. This is the 2984 chip. If you see here, we've got our sense resistors on channel 2 and channel 1 right here, okay? And then we have our cold junction diodes on. It's actually on channel 10, but for differential measurements, it's also on channel 9. We also have another 2K sense resistor here on channel 12. That's also on channel 11, so channel 12 and 11. And we have another cold junction diode on channel 20, or with its differential channel being 19. And we'll talk about this differential measurement here more in a minute. Okay, so the last couple things I wanted to point out were just the interrupt pins here. INT1, the SPI interface pins. There's a clock. There's a out, in, data out. This is master out, slave in. This is master in, slave out. This is chip select. And here's our reset pin. All right. And pay special, oops. I thought that was locked. Anyway, pay special attention to these caps right here. We're going to talk about so these caps C31, C28, 29, and 31, okay? Because we're gonna come back to those here in a minute, all right? So anyway, that's about it for the schematic. I just want to do a quick overview so we could, remind ourselves what we had. Okay, and so today, the last week I was using these data sheets right here, and actually the ATC data sheet isn't really a data sheet. It's more of a data book. So I think I'm just going to start calling it the data book because it is 78 pages long. So I'm also using the ESP32 data book. It's 59 pages long, but I was using these for the SPI or the SPI specs, right? And then the last thing I was using was this PDF that came with the LTC test bench zip file, and I'll show you that here in a minute. I wanted to show you this because I based a lot of my design on this example right here. So these are the protection resistors here. Well, this is actually forming a RC filter, and so the input is, so the probe would be out here, right, coming in this way, and which is, to me, a little bit backwards. I would have preferred the input to be, I would have preferred this on the left-hand side here, but anyway, that's the way it is. I know it's a little hard to look at backwards like this, but it is what it is. And here's our sense resistor right here, and this is the only reason why I use a 2K sense resistor right here, because he had it in his example. Otherwise, I searched this whole LTC data book for a recommended sense resistor size, and it was all over the shop, anywhere from 10K down to 100 megas, or not 100 mega, 100 ohms. So this right here is the universal temperature measurement example. I decided that this was probably the best. So once I got the COM working on this guy, I would tell it to start a measurement, and I was just getting junk. I mean, it was all over the shop. Nothing worked. This off-chip diode right here didn't work. The PT100 didn't work. I had plugged in just straight out resistors, to see if it would measure correctly, and it was just all over the shop. And not only that, I thought, okay, well, maybe there was a problem here. So I took these resistors are out right here, and the capacitors that go with them, and that's these guys right here. So this is that RC going into the channels right here. So I pulled these guys out to see, okay, well, maybe it's, there's a problem there. I messed around with how much, and here's the caps, by the way. They're just not drawn up here. They hang off right here. Anyway, so I pulled these resistors out. I pulled the caps out. Here's the diode. I've got another picture of it somewhere. Yeah, so I pulled this diode out and put a transistor in here. And as a side note, the LTC, if they ever watch this video, if you want someone to put a transistor in something, say transistor, because through this whole document, it says diode. Diode everywhere. It's diode. So here's the universal input, diode. Everywhere is a diode. And the only place they say transistor is right here, where they spec out this. They want you to use a transistor in here instead of a diode. Well, they actually call it a diode. They don't even call it a transistor. They call it a 3904 diode, which is actually an NPN transistor. And I actually saw that when I was doing this when I was designing this right here. It's right here, actually. And I thought, well, you can use a it's got, built-in diode, and it is they are pretty linear from what I understand. But they said diode everywhere, so I was looking for a diode that would meet the spec. And I picked one out, and works okay. I think the transistor works a little better. But anyway, so I had a 3904, so I went ahead and just cobbled it in there. It's very ugly looking, and that didn't help either. And I was just scratching my head. I was measuring voltages with the oscilloscope. I was adding massive amounts of debug statements to the code, as you noticed. And basically just beating my head against the wall. I mean, I read that this 2984 data book, I bet you 3 times from cover to cover. And then finally, I was probably on my 4th time around to read this thing. And I ran across this note right here. And actually, both these notes right here. And it said 2.5 volt, this is an internal low dropout, voltage regulator bypassed with a 10 microfarad cap to ground. And these guys right here are also need a 10 microfarad cap to ground, but it had this note of a X7R capacitor. And I was like, and that's for Q1 and Q2, and X5R for Q3. And I was like, well, I don't remember ordering any. I don't remember looking at the spec for this. And just so you know, right here, I did not change. This is the 10 microfarad cap. I had actually put it in the spec right here, but I didn't spec out that X7R. Or I shouldn't say spec. I put it in the schematic that there are 10 microfarad caps right here, right? And I went to DigiKey. Okay, so I went to my my account and looked at it, and I had those caps in here, right? I've taken them out since then, but they are this 10,000 puff cap, and I said, oh, okay, well, it's the X7R, okay, and here's where they were, and then I looked at this and said, well, this is 10 nanofarad, not 10 microfarad. That's like 3 orders of magnitude off. And sure enough, I went to the schematic and said, well, I spec'd out 10 microfarad. I wrote it in the schematic, but when I ordered them, I ordered 10 nanofarad. And in my defense, a 10 microfarad ceramic cap is very large, right? I mean, that's big for a ceramic cap. So, but anyway, yeah, so I was 3 orders of magnitude out on this guy bypass cap. And so I added these guys. These are some tantalums I just picked up at a local electronics store down the street here. They're 10 microfarad caps. I just put them in parallel with these 10 nanofarad caps. And sure enough, that fixed my problem. After 2.5 days of debugging this thing and looking at code and just scratching my head. So, yep, that's these guys here. I think I took a couple. Here's another picture of it, just across those caps. Here's that one of the diodes I got. I'm going to change this out. The footprint was wrong, and it doesn't read very good. I'll probably change this footprint out for these diodes to the 3904 NPN transistor. That seems to work pretty good. So here's the test setup. You can see here's the large probe is a PT1000. The braided one's a PT100. And here's how it's wired in. And on the PT1000 here, I'm doing a 3-wire measurement on it. I was just mucking around with it. And the PT100 is a true 3-wire measurement. There's a picture of the resistors I took out and the transistors. So, okay. So we looked at all the pictures. Okay, so now what everyone has been waiting for. So here's the chip. It's booting up. So you can see it's booting the ADC. This is that setup routine. And here's where it's provisioning all the channels, the global parameters, and that's it. Also, I left some of the debug statements in there so I could debug it in the future if necessary. So it should start measuring here in a minute. This is a nice little GUI setup. That might be good to use in the barbecue controller if I can squeeze it all in there. The code, that is. Okay, so channel 4 is our PT100 and channel 10 is our off-chip diode. That's that 3904 I've cobbled in there. And channel 17 is our PT1000. And so we got 24.96 and 25.48. So a little more than a half a degree off, I guess, between each other. It's not bad. Yeah, this off-chip diode, it's it's a little bit off. And I don't know, it's really kind of interesting. It might be because it's sitting on the board. So it's, if you remember the picture. Yeah, so here's the off-chip diode. And when they say off-chip, they mean off this chip. And it's kind of sitting close to that, this ADC. It might be getting warm. There's a LCD on the other side of this board that might be generating a little bit of heat as well. So I don't know. This might actually be right. This 27. I'd have to get my fluke out and mess with it a little bit. I'm not too worried about that right now because that's a bit how you doing right there. When I get it properly set up, if we still have problems, then I'll visit that. We seem to be about 25.18, 25.84. We seem to be about a little more than a half a degree difference between the two probes, which is pretty good. And it could probably be tweaked as well. Whew, boy, that was a pain. It wasn't bad. It would have been very smooth and quick had I not messed up the order. So anyway, don't forget, you can support the Muxall Open Internet of Things channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you like the video, give it a big thumbs up, that helps, and hit the subscribe button. That really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time. So, just as a side note, I went to lunch and messed around, did a couple other things, and came back and noticed that all 3 temperature probes are getting close to the same. The biggest one was this channel 10, this cold junction compensation, the transistor, NPN transistor. Well, that's kind of interesting. Anyway, yeah, so it's kind of interesting because, so now this is the PT100, and this is the NPN transistor, and now, see, this is 25, this is 26. Now there's almost a degree difference between the PT100 and the PT1000. That's kind of interesting. I mean, I do have a fan blowing in here, so maybe that's causing it to fluctuate. But I'll do another video on testing this and doing some performance testing with this in the future. Anyway, I just wanted to show you that this finally settled down, which is kind of interesting. Don't forget, you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button, that really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.